Hello, Gideon. How are
Hey,
you?
I'm good. I'm good. How's it going? Thanks for having me here.
It's a pleasure. Can you introduce yourself a bit before we move on with the talk?
Yeah, definitely. I'm Gideon. I'm the CEO and co-founder of Comet. Actually started my career as a software engineer about 15, 16 years ago and shifted to working on ML about 7 years ago. First, like a lot of us as a grad student, publishing papers and chasing conferences, mostly in like speech processing and NLP. I worked a lot on like language modeling within like speech recognition. And then I had another startup where we built like a chat analytics app. So we got to deploy a bunch of models to production. And then I was at Google. I was kind of doing deep learning research, working on hate speech detection on YouTube comments. And I think my team was one of the first ones that tried to deploy a TensorFlow model to production, which was it's,
Awesome.
it's still painful today, but it was harder then. But yeah, but it's awesome to like being able to work on like these tasks on such a scale, like the entire YouTube comment corpus it brings a new set of challenges for sure.
I just loved how you have done all of these things. It's a lot. Why? How and why did you start doing deep learning rather than just moving on with software development?
So I think like a lot of software engineers that are now doing machine learning, I got stuck with a problem that's hard to solve with traditional software. So I'm happy to share. I mean, one of the projects we are working on is building speech recognition models for low resource languages, so not English or Spanish or German and so on. And with speech recognition, one of the challenges you have is like, in a lot of NLP problems, is the out of vocabulary problem, right? Like when you've never seen these words, like how can you predict them? So we built like a web crawler that essentially collects data in a bunch of languages just to increase the vocabulary size. But we had a really awesome system and we got data in a bunch of languages. But then you get a string in, let's say, Lithuanian or Turkish. How do you know it's actually Lithuanian and Turkish, right? Like, so I started like Googling Stack Overflow, and the typical approach, I guess, a software engineer will try to apply is like using regular expressions or stuff like that. But obviously, it doesn't work as well. So, and then I started reading about language identification, which is essentially a subtask of document classification. And I was like, oh, this is pretty cool. Looks like it could work. And I trained my first model, and I don't even remember the name of that library. It was a Java-based one. It wasn't Weka. Um, so yeah, that was my first kind of modeling endeavor, and I guess I fell in love since then.
We all do. I also, when I met data science, I was doing with R, and I was like, I'm going to make this my job, and I'm not going to do anything else until I do it. And I have basically shifted my career.
How was
So,
it to move
can
from
you
art?
talk
Oh, sorry.
about Comet a bit?
Yeah, definitely. I was about to ask you how was the transition from R to Python, but we can. I'm curious to hear about that too.
Yeah, let's talk about this later.
Yeah, but happy to tell you, of course, about Comet. So essentially, what we do is we work with data science, machine learning teams, and our platforms allows you to manage and track the development workflow. So you can track for each experiment or model run where the data came from, what code did you use to train that model, like all the hyperparameters, all the environment variables and dependencies, really everything that is required for reproducibility purposes. So, and then once you train a bunch of models, you can do a deeper analysis. So you can compare two models. You get one of them is like 97 AUC, the other is like 96.9, even though they're very different. You want to kind of dig a little bit deeper and try to understand. So we have a lot of like tools and visualizations to do that. And then down the road, when you're ready to go to production, we'll also package the binary, whether it's coming from TensorFlow or scikit-learn, and give you access to, you can integrate to any like open source or cloud solution to deploy it. And yeah, that's on a high level. The exciting part is like, it's just like you copy paste 2 lines of code into your script or notebook and it works. So it doesn't matter if you train it on your laptop or on Amazon or whatever, it just works out of the box.
That's kind of an end-to-end all-in-one machine learning platform. That's how I hear you.
Yeah, so I think, we were chatting before that a little bit about what's MLOps, right? But I think all-in-one is, I don't even know if they're all-in-one platforms at this point because the scope is so large. So I can tell you what we're not doing. So we don't consider ourselves all-in-one. We don't handle like the infrastructure orchestration, like the CI/CD stuff. So we don't do any of that. We just integrate with like best of breeds. We don't provide like feature stores or kind of like online feature fetching and so on solutions. And then, obviously there's a lot of other pieces like feature engineering tools, model compression. There's just a lot of other pieces. So our focus is solely on like the development side of models. But yeah, there's so many things depending on the use case. So we don't try to do everything.
I get it. What are the challenges in, coming up with this really end-to-end kind of platform, by the way? I really wonder.
What are the challenges from our perspective, like the data scientists or just building the product?
Yeah.
So I think one of the things that were like super important for us and for me, like when we started working on the product, is we didn't want to force you to like use a specific tool or library or anything like that. So we really wanted to be agnostic because, I worked on an ML and sometimes you want to use TensorFlow or PyTorch. Sometimes like you should use like a linear model or something simpler. Sometimes you train models on your laptop for a few weeks and then go to like run like more kind of heavyweight jobs on the cloud. So what we did is like we built something that's agnostic. So it runs in runtime. So as long as your script's running somewhere and has a network connectivity, it will work out of the box. So from that perspective, it's very like non-opinionated. And then the other thing is that we didn't want to slow like the data scientists down. I think one of the challenges of teams that try to use like something like Git to version control, not just code, which is definitely the right way to do it, but experiment results and so on is, data scientists want to move quickly. We train them all many times, make a small change, we run it again and again and again. And it's just like, if you have to commit every time you make a small change, it will like significantly slow you down. So our approach was like very much different. Like if you're running it, we're auditing it and kind of giving you that thing automatically. That said, like, I do believe that in order for a data science team to be successful, that there should be some process and the like best developer practices as you're working in a team. So, if we're working on a modeling task and I want to share that with you, I can send you like a Comet experiment and you'll see everything I was working on. But it does require from the data science to have a little bit of discipline and like just making sure that everything that's relevant is logged.
That kind of makes me wonder how much of the machine learning model life cycle do you actually cover? Like, does your platform cover? And you can actually talk about...
I think I lost you. Okay.
Can you hear me?
Yeah, you're back now. Yeah.
So can you talk a bit about the machine learning model lifecycle and how much does Comet cover it? Like, when are the data scientists going to be unemployed?
Oh, no, yeah.
That's a very cliche kind of thing to say because of all of the AutoML platforms coming up, and people really wonder, oh, we are going to be unemployed. It's just like, GPT-3 just saying something, printing some code, and software developers are like, oh, we are going to be unemployed. I just kind of like to bring it up to, prove the opposite most of the time, because not much of the platforms actually can cover most of the data science practices.
Yeah, no, I couldn't agree more. I mean, we're not an AutoML solution whatsoever. We're actually the exact opposite. We're like code first. We're like for people who are building the models themselves. I think in general, like AutoML definitely can provide value, both on whether it's like very simple modeling tasks where you don't need anything fancy, or just for if you're working on something that's a little bit more complicated, it's just like establishing a baseline pretty quickly, and then really diving deep. But we have integrations with AutoML solutions, but we definitely don't like focus on that. And quite frankly, like our customers would never be able to like use AutoML to solve their problems. Like, Uber is using Comet to manage their experimentation and models and so on. And, the level of complexity that they have, like, it's just impossible to like expect an AutoML solution to solve all your problems. And I think, anyone who worked as a data scientist at like an organization knows that part of the work is like bringing the business knowledge into the process.
Yeah.
Like if you're doing feature engineering, something like that. Yeah. So, and that's something an AutoML solution would never be able to do. So I don't think we're going to lose our jobs anytime soon. Yeah.
Again, how much of the machine learning model lifecycle do you support as an MLOps platform?
Yeah, so that's a great question. So we focus on what we call artifact management. So we can manage your data sets or any other artifacts that are part of the modeling process, whether it's the trained model or configuration or anything like that. So data set management, experimentation management and tracking. That's a really core part of our offering. We have a model registry, which is just managing the binaries of the trained models. And that is our core focus. We do have another product that's focused on production monitoring, but it's actually a separate product. And it's only available for existing customers at this point. So yeah, that's what we focus on. So really like the people who use Comet are the same people building the models. Some companies are data scientists, some company machine learning engineers, and some companies are software engineers, but it's not like the DevOps people. It's not the people focused on productionization, really like data scientists training and fitting models.
Also, can you talk a bit about how much does machine learning model lifecycle actually differ from regular software development practices? And is there actually such thing as MLOps?
Yeah. So yeah, I do think there are differences. There's obviously a lot of overlap, right? And I think what most people and teams do the first time they kind of start working on modeling and in a certain scale is try to adopt what they know from software engineering, right? And sometimes it works and sometimes it doesn't, right? But we talked a little bit about the Git kind of story use case. Like Git is the de facto best way to manage code. I mean, there's no argument about it, but like in ML, like code is just one small piece of the puzzle. You got data, hyperparameters, other configurations, results. All of that stuff doesn't fit well into like the Git paradigm. We've seen teams try to like create a branch for every experiment, but then it just gets a little bit muddy pretty quickly. So that's one difference on like more, I guess, the workflow. But if you think about it as a process, it's actually very different. And software, with most, like the vast majority of software products and problems, with enough engineers and enough time, you'll be able to build it. In ML, you might succeed in 2 weeks and you might continue, you might research for years and not be able to like build a model that's successful. So from an organizational perspective or R&D, it's really hard to estimate how long would a machine learning project would take, right? Like a lot of companies were like, oh, we want to build a model to like, I don't know, forecast churn or do something in the product. But when you approach the project, you don't know if it'll succeed beforehand. So that, I think, is like the core difference, more on like the process side of things. And then on the tool side, yeah, I think versioning and experimentation is very different. Where it is very similar is deployment. I don't think deployment for ML is different than deploying an application. I mean, I think what we have in the CI/CD world is like a very good fit for these use cases. It's just a binary. I mean, it behaves the same way as like a web app in many ways. There might be some differences like on the inference engines and optimization and such, but the process of putting it into production is very similar. The process of running training jobs is like running data batch jobs. There's not a lot of differences there. Monitoring is also an interesting one because you need kind of like infrastructure monitoring, which is what you have in software. You probably need APM, what like Datadog and New Relic offer on like endpoint and analytics and so on. But then with ML, like, you have this additional layer of monitoring drift and seeing how features behave in production and so on. So I do, obviously a little bit biased, but I do believe MLOps is a real thing. I just don't think we have to reinvent everything. I think there's a lot of things we should just take from software engineering and use because these tools are like really good.
Indeed. Yeah. And what are the challenges, like main challenges of actually implementing MLOps if you are doing it either in-house or doing, using MLOps platforms as a company?
Yeah, that is a great question. There's a few kind of aspects to it. So I think the first challenge or decision that these like MLOps teams or platform teams need to make is, are we trying to buy or build end to end, or we're going the best of breeds approach, right? Quite frankly, like I think that there's very few, if any, full end-to-end solutions that are good enough, and that's because it's just such a wide scope, right? If I would come to you as a software engineer and say, hey, I have this one platform and it's going to replace GitHub and AWS and Circle CI and Jenkins and Datadog and everything, you probably like not take me very seriously because it's just so much scope. And I do think that like in the MLOps space, we're seeing that happening as well. So that's the first challenge. And then if you go the best of breed approach, you can like plug in different vendors and open source solutions and also adapt it to your existing stack. So you can use like something like Comet for experiment management and your existing CI/CD system for deployment, any cloud provider, and you can switch between them for orchestration. So you just get a lot more flexibility there. That I think that is like one of the biggest decisions these teams have to make, and one of the challenges. Other than that, and this is more on like enterprise organizational thing, is if you are like an owner of an MLOps platform and you're trying to dictate like one workflow, like how things should be done, it's really tricky because as data scientists, we want to pick the right tool for the job. Sometimes we want to use a notebook. Sometimes we want to run like a full like distributed training job, and sometimes like we want to run like a simple model on our laptop because to get the sense of the data, right? Like, and it's really hard to like force a single workflow. It just rarely succeeds because people start doing things outside the platform, and then you're back at square one. So that's where we see the most of the challenges out there.
It feels like what your platform is basically doing is to orchestrate some of the really important MLOps processes and take the weight off of data scientists and other people's shoulders by, enabling them doing really important work, just doing inference, taking the meaning out of the data, experimenting around with models, and I quite liked it, to be honest. I have never used it, but
yeah, definitely.
How did you come up with this, by the way? Did you just see, hey, this is actually a process that can be automated, and why are we just bothering machine learning engineers and data scientists with this? This is so messy. Let's come up with a solution like that. Is that how it was founded?
Yeah, that was, I guess, later, but my experience was, so when I joined Google, the first 2 weeks you go through like the developer boot camp, and they teach you how to check in code and their code styles, and they're like the experts in that. It's like amazing to see like the entire code base, like with the same, everything is like beautiful. But then I joined a team of machine learning engineers or scientists, and one of my tasks was to try to beat the production model, right? So again, we're working on hate speech detection and YouTube comments, and we were trying to beat that model, which was like a combination of like a deep learning feature extraction method and like a simpler classifier on top of that. And we were also hoping to publish a paper as well. So I asked them, like, hey guys, like, have you ran any baselines? Like, what do I compare this to? Like, other than the production model, what else have you done? They've been working on it for like a while, because I wanted to get in and just focus on the cool stuff. But and like, to my surprise, like, they had a very hard time answering that, right? Like, there were some emails, some slides, but there wasn't like a system of record of all the experiments, all the modeling that they did. It just wasn't there. And I knew that if we want to, publish a paper to like ICML or something like that, we have to be very rigorous and show like very clean and clear baselines. So I was like, okay, like, let me spend like a month or two. I'll just baseline everything, and then we'll take it from there. And if you're working on document classification, I'm sure you know, like, I picked the simplest approach: logistic regression, stop words removals, n-grams, of course, and like stemming, like really like the basic approach for document classification. And after a little bit of tuning, like within a month or so, we got better results than the deep learning production model. And I was
Awesome.
like, what? How did that happen? Right? Like, this doesn't make any sense. Haven't you tested this before? And so on. And that really, like, at that point, things really clicked. I was like, okay, we can be really smart data scientists and know all the best algorithms and techniques, but like, if we don't have a process, it's going to be really tricky. So at that point, I called my co-founder here at Comet, and I was like, we worked together before at ML. And I was like, dude, this is like the exact same thing we've seen at our previous startup. Let's fix this. So that's kind of like how we started.
That's awesome. Do you also benchmark, I don't know, different processes of pre-processing, for instance?
Yeah, so definitely. So the platform is very flexible, so you can log any metrics that you want. So if you're trying different pre-processing methods, you can, of course, and if you have intermediate metrics, you can report them. But if you have like the downstream metrics, that's a really good use case for Comet. So let's say you're trying to train a model and you're using different tokenizers. You'll have a row in the UI for each tokenizer with all the results, and you can compare and you can look at the data and see, oh, okay, this tokenizer got a better result, and you can see why. You can actually look at the tokens. So that's a very standard use case, that we support.
The first thing that came up to my mind was that, most of the process of a data science lifecycle is pre-processing, and you can actually make dramatic difference with a different tokenizer. So it would be actually great to also benchmark that one.
Yeah, definitely. And then you can also benchmark like performance, right? Because in some cases you might get like I'm talking about like CPU, GPU performance, like So definitely, like working on the data is typically what would give you the best bang for the buck. So we try our best to support these use cases.
I'm one of those people who defend smaller models that have better use cases instead of going with a gigantic model. So I'm definitely up for that, because it also damages the environment and stuff. So I'm always fond of going with, if there's a smaller Occam's razor kind of approach.
Yeah, I'm Couldn't agree more. Couldn't agree more. I mean, it's sometimes it's fun to build like the crazy models, and that's okay. But like when you're kind of production and KPI oriented, if you can build a small model that works fairly well, like do it. I mean, you're just gonna make your life so much easier. Yeah.
Also, like, first thing comes up to my mind, that would be awesome if someone could actually use, there are few AutoML tools like Teapot or simply a grid search cross validation results, and just visualize it and keep it nicely. Like, as a person who loves, being organized, I actually love your platform.
Yeah, yeah, no, we
Um,
support, that's what I said. We have support for like AutoML, so Teapot and AutoKeras, as well as like the commercial ones. So yeah, that's definitely one of the use cases. I mean, Teapot is amazing. I think it was before all
yeah.
the other content. It's such a great tool. Yeah.
Yeah. Also, people do ask me. I'm kind of I was a MLOps nerd. In my previous job, I used to do many of the things that you were talking about, as well as the data science stuff, because it was a rather small company, and people
Wow.
used to ask me, "How did you learn doing MLOps?" And I had, I just read few blog posts. I had this introduction to MLOps book, but if you would give advice to people who would get into learning MLOps and machine learning model life cycle and other stuff, would you have an advice for them?
Yeah, I mean, I think there's a lot of good content out there. It's also important to recognize that this is like changing very fast, so it's important to keep up to date. One of my favorite kind of resources is the MLOps community. I think it's mlops.community. I'm happy to
Yeah.
share that on the post later. And that's just a group of industry and academia people coming together and thinking through this thing. It's not commercial. There's no vendor behind it. And there's just a lot of good resources there. So that's a good spot to start with. Yeah.
Also, when how does it change by time? Like, what is being improved in the MLOps processes through time? What's your observation?
Yeah, so it's a good question. I think there's a few things. I like we talked a little bit, but before the original like MLOps platforms were completely end to end, and that's kind of like the first wave. The second wave is very much like best of breeds, like we're trying to do, like do one thing but do it really really well, rather than like spread yourself super thin. That's one of the biggest changes that happened. I think other than that, I think the concept of feature stores is starting to pick up a lot of a momentum, and for good reasons. I think it's a hard problem if you're trying to do inference at scale. If you're trying to make sure that the features you trained on are the same one you're predicting on, there's a lot of pain points there. But like just to give one example, like the majority, I think quite honest, I think all the feature stores are focused on like tabular data. Excuse me.
Mm-hmm. Yeah.
But what about like images and videos? And so there's just like a lot of things that are kind of moving. And then the other piece is like the monitoring piece, which is slightly newer. And that's because, these teams who got to production, and we support a lot of teams that have models in production. Like I mentioned Uber, but also like Etsy, the Real, Zappos. There's just a lot of other teams. And once you put that model in production, typically other people in the organization care about it more. So like the product manager, the line of business, because it affects revenue or results, right? So
Yeah.
if things starts to go wrong there, it gets a little bit trickier. So that's why I think monitoring is getting a lot of momentum as well, because teams started to like feel the pain there. So I think those are like the main trends that I'm seeing. And honestly, like again to your point before, is that like AutoML will not solve all your problems, and if you want to invest in AI, you have to build like a team of data scientists. Yeah.
How do you monitor, by the way?
How do you monitor what?
Yeah, you said earlier. You said you are also covering. You are auditing and monitoring the models. How do you do that?
Yeah, so that's a hard problem, but generally speaking, there's a few things that we offer there, right? So the first thing is like you want to monitor concept drift, right? So imagine if your models, what I don't know, was trained on user features, and you have country and age and so on. And let's say the majority of your customers when you train came from North America. You train the model, it's really good, you put it in production, but then like the marketing department launches a campaign in Asia, and suddenly like 50% of your users are from Asia. The feature distribution changed, right? So we
Yeah.
detect that, and we tell you as a data
Awesome.
scientist, yeah, it's like, hey, like you might want to retrain your model because like the distribution shifted. And also on the prediction side, right? Like if your model predicts in training or validation, like 90, I don't know, like if you're doing like fraud or something, so 99% of the predictions are false and 1% is true. But then suddenly in production, it looks like more like 90-10, then there might be something off there. So that's kind of like another use case for monitoring. But then what's really cool is you can actually look at the production predictions and as a data scientist and see like the weights, the features, and just really like see how your model is in the real world. So it's a lot of fun.
What is the best feedback you ever got from a data scientist? Or I guess this is a great platform to run developer advocacy as well, because what you are basically doing is making the lives of data scientists and ML engineers easier. So I suppose you get a lot of feedbacks from them because it's an ever-changing world. It changes a lot. You
Yeah.
also need to adapt as an MLOps platform, right?
Exactly. Yeah, you hit the nail right in the head. That's the most important thing, and that's why we stay so close to the community and the data scientists. And by the way, the platform is completely free for individuals. So
Mhm.
there's a lot of people, academics and ICs using the platform. The best feedback I'll never forget. I was at the AI conference in San Jose or San Francisco. I was eating lunch at the conference and speaking to someone, and then somebody comes out of the blue and is like, I guess I had a Comet backpack or something, and he said, "Oh my God, you work at Comet? I love Comet." And everyone at the table was like looking at me, "Whoa, who are you?" So that was a fun moment for sure. Yeah.
If individual use is actually free, I would like to try it for Kaggle, because I'm planning to start Kaggling right after the semester ends, and I think that your platform is actually great to run, Kaggle experiments and stuff, because you have to benchmark so many things.
Yeah.
What have I done? It's like a Kaggle diary.
Exactly. Yeah, yeah. And we have a lot of Kagglers, including like grandmasters using the platform. So that's very much a yeah, yeah.
I
So
was missing so many things. Like my whole life was a lie.
I hope you win. Yeah, let me know. Do you know which like competition you want to try? Is there something specific?
I'm planning to go with NLP competitions. I will see, but it's great. Like you learn so many know-hows in the process of doing it, and if you can actually keep a sort of a log diary, keep your benchmarks and everything all in one place, then it's very
Oops, I
powerful.
think I lost you.
So I said, if you can actually keep something like a diary, something like a log, and you can log all of your benchmarks, what you have done so far, what works, what didn't work. In fact, most of the Kagglers, according to my observation, are actually having a discussion forum for every competition, and they are talking about what worked for them, what didn't work for them, and they learn a lot from each other. So I just thought that it would be a really powerful thing to actually log your benchmarks for your preprocessors, for your feature engineerings, like which feature was actually good, which one was bad, which model did work, which one didn't. That's actually a great platform then.
Yeah,
I
no,
have never imagined, like, before our talk, I kind of took a look at it, but I didn't imagine it to be like that. Like I am very impressed at the
For
moment.
sure, yeah. Definitely take it for a spin. And then once you're done with everything and you got your best model, you can also use Comet for hyperparameter optimization to try to squeeze
Awesome.
a few extra points on the leaderboard. But yeah.
It was a great chat with you. I hope we will just, let's make it annual. Like you can keep me out to date with all of the MLOps waves and stuff.
Yeah, for sure. It was awesome to chat with you. Thank you for having me. And I'm still curious how was the transition from R to Python, but we can pick it up another time. But yeah, again, thanks so much. And if anyone in the audience have any questions about MLOps or Comet, feel free to shoot me an email. It's Gideon, my first name, Gideon @comet.ml. And you can also go to comet.ml to get a free account. I think I lost you again for a second.
Yeah, can you type it through private chat so that I can post your email and also you can type the MLOps community you were talking about.
Should I put it on this platform, on this chat? Yeah. So
I think I'm back. I don't know. The universe doesn't want me to get back to podcasting, I guess.
I put it in the chat.
Okay, let me post these. I have told the audience to ask questions, but apparently they don't have it. Yeah, I just posted it. Thanks a lot. I will we can have a chat about my transition from R to Python. It was quite hard. At first I learned the R for data science, and then I took a class that I was doing, optimization. I was doing simulation. I was doing I don't know, Monte Carlo kind of stuff in Python. I had zero idea about object-oriented programming. It was my first time, and it has shown me tough love. And then, my transition to Python for optimization, from Python to optimization to Python for data science was really smooth.
I think I guess ggplot or matplotlib, which one's better?
Matplotlib.
Yeah.
Seaborn.
And Seaborn for sure. And Plotly is also amazing. Yeah. I know ggplot is pretty strong, but it's been like a good 7 years since I touched R. So
yeah. Thanks a lot for coming.
Awesome. Yeah. Thanks for having me. Bye-bye.